Okay then, we got to do what I call today advanced food chains with your bit this way. Superb. Now the idea about an advanced food chain is, well, the same as a normal food chain. I have grass, and I have rabbits, and I have foxes. My simple food chain here tells me rabbits eat grass and foxes eat the rabbits. What I can also do is, rather than draw a food chain, I can actually do what's called a pyramid of number. And actually show how many live at every step. So I could say, for example, hey, there's maybe foxes here, maybe there's 50 of them. And maybe those 50 of them are eating, I don't know, let's say 300 rabbits. And those rabbits are eating, I don't have enough space on here, but let's say 10,000 pieces of grass. That there would be my pyramid of number. This is much bigger because there's more bits of grass than there are bits of rabbit, than there are bits of foxes. So overall, you can see that it's going to get bigger and bigger the bottom we go. This kind of shape here, this is normal. Usually there's more at the bottom, at the top there's less. Because we know top predators are usually really, really big. It's not always like this though. I can have one that's a bit of a weird shape. I could have maybe some birds. Let's have birds. Let's have 20 of them eating caterpillars. Let's say 50. And it lives on one tree. One huge tree. There's only one. My pyramid number doesn't really look like a pyramid. Number, how many there are, is good, but it's not the best thing we can use. We can actually instead use what we call a pyramid of biomass. That basically means the dry weight. Can you see that? Yes, you can. The dry weight of an object, that's the biomass. And a biomass pyramid, for that one there, would be this shape. Tree. Caterpillar. Bird. It would always be this shape because the tree would weigh more than the 50 caterpillars. And the 50 caterpillars would weigh more than 20 birds. Always going to be more mass at every step of the chain. The weird thing, though, is why does that mass always go down? Well, we have to remember what happens when any animal eats food. It happens to us as well. Any animal, let's draw. This is random animal. Random animal eats food. Some of that food comes out the other end. Think about it. The food you eat, some of it goes in, and then out the other end. I'd say about, well, quite a lot. Some of that there is what we say is excreted, or you could just say poo. Some of it is waste we don't want. Some of it, hey, we need that energy. We need it to live. We need it to move. We need it to keep warm. We need it to do that chemical equation called respiration. But to ask you a question in that, in the homework, we need it to do respiration. We need it to make energy. What it is that's left is about 10% of all the energy that is eaten by any animal is actually used for growth. Max. For growth, for repair, about 10% of the food we eat. Most of it's for energy, some of it comes out as poo. So, it's not good enough. We can't have it going up perfectly all the time. Every step here, there is energy lost. Every step has different amounts of energy lost from my pyramid. And that means the pyramids can't go forever because they get smaller and smaller at the top. Usually a food chain is no more than 2 or 3 different things. And that's fine. It means that top predators can't be eaten by anything else because there's not enough predators up there for something else to eat it to live. So food chains are only usually 2 or 3 steps long total. What this means is, and this is the question for the end of the homework. If I do this here, every step wastes energy. The simplest thing I can do for an animal is that. 2 steps. Plant, eaten by animal. That is the simplest food chain. Why is this better than doing this? Why is that better for the environment? That's the question at the end. Have a go. Thank you very much.